What if I told you that encrypted data being transferred across your networks today could be decrypted by your competitors or nation-state actors in just few years? This isn't a science fiction. It's the quantum computing, a reality we face. I've developed a comprehensive AI-driven system that not only detects vulnerable encrypted traffic today, but also optimizes quantum-resistant implementations for better tomorrow. The quantum computers will break widely used encryption standards like RSA and ECC. Nation-state actors already are harvesting encrypted traffic in store now, decrypt later type of attacks. Organizations lack visibility into which communications are vulnerable, and post-quantum cryptographic adoptions in is happening really slow. Security teams need a practical solution that can be implemented with their existing infrastructure, and that's what we've built here. My solution introduces two key components, two key innovations. The first one is an AI-driven system that analyzes network traffic, network packets to identify any traffic and secure vulnerable cryptographic algorithms, enabling immediate alerts through existing security solutions. The second one is a machine learning framework that optimizes post cryptographic implementations, ensuring organizations can effectively implement quantum safe communications without sacrificing the performance. The key components of our project are network traffic cryptographic vulnerability detectors and quantum resistant parameters optimization. The network traffic cryptographic vulnerability detection, it essentially is an AI-driven identification of quantum vulnerable communications and delivers real-time analysis with minimal false positives. The quantum resistant parameter optimization is essentially a machine learning framework that optimizes post-quantum implementations. The best part about our project is the vulnerability detection model achieves perfect 1.2 precision with 0.9991 recall across all vulnerability categories, with a processing time of 0.7 milliseconds per record, enabling real-time traffic analysis without performance impacts. The real-world impact of our solution is assume it as if a security analyst provides a visibility into cryptographic vulnerabilities that are invisible to current security tools, reduces alert fatigue by intelligently grouping related vulnerabilities, focusing first on the most sensitive communications. Now let's go into the live demonstration of our project. We'll dig deeper into the results once we are done with the basic demonstrations. Here we can see all the dashboards and all the results that we have collected so far, which are being generated. It will be in the presentation deck as well. Here, as you can see, that we are running quantum resistant vulnerability prediction algorithm that we have developed. All these results again will be discussed within the presentation as a whole. This is the vulnerability comparisons across all the categories: Letty, side channel, misuse, implementation, and quantum for Kyber 512, Kyber 768, Kyber 1024, and our AI optimized algorithm. Again, a vulnerability comparison chart. This varies every time we run the code. This is an overall vulnerability comparison chart. Here you can see that our model is being trained for a total. It is generating 1,000 sample sets, and it's generating all the training data by its own and training the entire system as a whole. As you can see, the accuracy is 1.2, precision is 1.2, recall is 1.2, and the F1 score is 1.0 with a 0% of false positive rate. This is again, all this will be dealt once we are going through the slide deck. This is again alert severity distribution. This varies again every time we run the code. Essentially, we are not feeding a real-time data right now. We are generating logs of data, tons and tons of logs of data, and that data is being trained against the model which we have developed right now. This is the dashboard, typical dashboard security analyst looks at. The parameters can be varied, and based on this, the security analyst can make changes in distance by changing the polynomial value and all. Yep. Just want to emphasize on a small part here, which is, yeah, this is it. So here, as you can see, that total 92 alerts from 100 traffic samples. The sample alert will look like severity critical, vulnerable data, and the strategic recommendations that it is giving to rectify the vulnerability. Keep in mind that this is only a proof of concept, and this is not a production level code as a whole. Now let's get back to the presentation. Okay. First one is comparative analysis. This is a terminal output that shows ML approach compared to the rule-based detection systems with a precision and a recall of 1.2 and 0.9991. Coming is our detection dashboard, which provides a comprehensive view of network cryptographic security postures. The top right pie charts describe the severity levels of 45%, 37%, and 15%, with just 2% of critical vulnerabilities. The top left one shows various categories where vulnerabilities are present right now. The leading ones are deprecated algorithms. Now this is a parameter optimization radar chart. This radar chart demonstrates the core innovation that are AI optimized cryptographic parameters that has achieved. Our solution has achieved better balance across key size efficiencies, encryption speeds, decryption speeds, and security. Now let's look at the fitness improvement over generations. The graph visualizes how our genetic algorithm optimizes parameters over time. This automated optimization process would take cryptographic experts weeks to perform manually, demonstrating the power of applying machine learning to cryptographic parameters selection. Now, a comprehensive parameter analysis dashboard. This is a dashboard again, which which a security analyst will be interacting with. The slide bars you can change the values of polynomial, etc., and eta modulo to see how the cryptographic algorithm handles and works in regards to in comparison to the other algorithms which are existing right now. This is a parameter sensitive analysis. This is a sensitive analysis that shows individual parameters change effects with different vulnerability types. This analysis helps security teams make targeted adjustments to address specific vulnerabilities without sacrificing performance, knowledge that typically requires deep cryptographic expertise. The vulnerability comparison bar chart, this is again across all different categories. Here we can see that our AI optimized configurations, which is in yellow color, achieves the lowest score in most categories, particularly the lattice attack resistance of 0.03 compared to 0.03 to 0.04 for standard configurations. The vulnerability radar detection, this radar chart shows vulnerability profiles across 5 different dimensions. Lattice attacks, side channel attacks, misuse vulnerabilities, implementation flaws, and quantum threats as a whole. This balanced pentagon shape indicates no single point of weakness critical for cryptographic security. This balanced protection ensures that addressing one vulnerability doesn't create weakness elsewhere, a common problem when manually tuning cryptographic parameters. This is again our training performances across the model loss, mean absolute errors, and the mean square errors. So here, training blue and validation orange lines track closely, indicating the model generalizes well without overfitting. The model converges rapidly with 25 epochs and maintains stable performance thereafter. Now let's see the real world impact that our project creates. This solution delivers immediate benefits to security teams. It provides visibility into cryptographic vulnerabilities that are invisible to current security tools. It enables a phased approach to quantum-resistant cryptography with focusing first on the most sensitive communications. Security analysts don't need to become cryptographic experts. The system provides clear, actionable guidance within the existing workflows that security analysts use right now. This is a 9-month implementation roadmap with phase one delivering code detection capabilities, phase two validates the system in production environment, phase three expands code capabilities, and adds automated response workflows over the coming 4 months. Why this matters. This solution bridges the gap between theoretical post-quantum cryptography and practical network defense by providing immediately useful capabilities while preparing for quantum threats. It addresses both current vulnerabilities and future quantum risks through an integrated approach that security teams can deploy today. Most importantly, it enables organizations to implement quantum resistant cryptography where it matters the most first, balancing security and performance in practical and actionable way. In conclusion, in a world racing towards quantum computing, security teams need practical tools that they can work today. By identifying vulnerable communications and optimizing quantum resistant implementations, we are helping organizations to protect their sensitive data against both current and future threats. Thank you so much for your time. Signing out, Aditya.